Hi everybody, I'm Antonio Valera Pascual and this is my presentation of my second assignment whose goal is to develop a test encryptor based on a genetic algorithm. First of all, I'd like to make a demonstration, so I have to MATLAB, CLC, and execute my program. Okay, back to the presentation, and once the presentation is done, I will check out the results with you. So, okay, which encryption problem is my program designed to solve? I have chosen to solve the most simple uh, case, which is the permutation of an alphabet characters. I have chosen the ASCII characters, which are 26, and this gives me 26 factorial possible solutions. So, as far as it is the most simple way of encoding, it is not as simple to solve. And the objectives are, of course, to develop such a program and also test its finest function as the ideality of using a genetic algorithm to solve this kind of problems. How does a genetic algorithm works? It is very simple. For a given population of individuals, which are the keys of decoding, I will evaluate them with a fitness function. I will select the most fit uh, individuals, and then they will mutate and reproduce. These child and mutants, along with some newcomers, will form the new generation population. A control function is usually included that will provide feedback of the ongoing process. Let's talk about my genetic algorithm. To speak the truth, I have not developed the whole program because I have used a genetic algorithm structure developed by Manuel Soria, downloadable in this web. And my labor has consisted in developing the individual functions that work within this general structure. Listed below, you have some of these functions, such as the newcomer function that returns a random alphabet, the initial populations, which returns a group of random alphabets. Here you have some examples. The reproduction function that will give from a parent and a mother an alphabet, a child alphabet that will with reasonable resemblance to its parents, a mutation that for a given alphabet it will permutate up to 5 of its characters, and a external control function that each 2 iterations of the genetic algorithm will print the best current decoded text in an external text file, so it can be studied without compromising MATLAB calculations, and also a fitness evaluation function. Along with these functions, there's other factors that compromise the behavior of the genetic algorithm, such as the population distribution achieved iteration. I have found this particular distribution to be particularly efficient and behave the way I like. So this is the one that is set in the default parameters of the program. Okay. Finding a suitable fitness evaluation function is very important because it will define how much time my program will need and if the program converges or not. I have chosen two possible approaches, which are letter phrase frequency and word recognition for the evaluation system. So let's talk about letter phrase frequency system. As the name states, it is based on information that can be found on the internet in the format of a table. Each cell of this table represents represents the probability of the frequency of finding the two associated letters together. So for my coded text here, I will just work it once, saving the marks for each pair of consecutive letters and then submit. So my fitness function will be the inverse of this sum. It will be the inverse of the sum because the genetic algorithm will minimize the fitness function. The advantages is that this method is very quick, and the disadvantages are that it is completely dependent on frequency information quality, such as if I am decoding, I don't know, specialist text such as scientific essay, my frequency data might not be accurate. Okay, below I have represented a convergence study. I have represented the fitness function as a function of the number of iterations for 3 different attempts of decoding of the same text. And I have found that as the iterations increase, the speed of convergence decreases a lot. For my word-based fitness system, I have downloaded the RAE official database and I have processed it, so it is now organized by word length to get a faster access to information. This has been fulfilled using self and structural arrays. And the first possible way of qualification is to count the number of words. Of course, doing this, I should prioritize larger words before smaller words. To do so, I would, when finding a large word, I would isolate it from the text, like here, and then I will search for smaller words within the non-isolated text. This way, I prioritize large words before smaller words. The advantages of this method is that frequency data is not required, but there is a fatal problem, that is that if my initial population is not very similar to the proper solution, actual words will not be found. I will only find some noise within 1 character, 2 character, 3 character words, but that won't be representative of the solution quality. So this method is totally discarded. Okay, having discarded the previous method, I have invented something that is a word likely function. This function for a certain buffer, which is a certain number of consecutive characters of the text, we evaluate how similar is this buffer to words, or how likely is this buffer to become a word. This function will increase with the right number of characters in relation to the word length, and if the buffer is actually equal to a word, its mark is will be a lot. Having these 3 things in mind, I have tested a lot of functions, and I have found the one in between squares, to be efficient and to behave the way I want. Here below you have some samples of the mark and match obtained for certain words, certain buffers. But the database I have downloaded from the official website also includes words frequency data, so why not use it? In this direction, I have chosen another function, which is the one between inside the square, and I have plotted the mark and the match for the same symbols with this new function. Okay, but this requires a further test. This requires further testing. So for the text that can be found on top, I have computed the total mark of the buffers of lengths between 1 and 19 for this text. I have represented the logarithm of this fitness. The blue ones belong to the right key, and the red ones belong to a totally random key. So as you can see, for very small words, the difference between the right key and the random key is not enough. In order to minimize this noise effect, the final fitness function is standardized, so if the values of this mark are next to the random key result, it equals 0, and if they are next to the right key result, if it equals 1. Having done that, I have found that this method is very costly. It might spend days to find a suitable solution, and disadvantages are that it does not necessarily need frequency data because it's based mostly on word recognition. So, being such a slow uh, process, how can I assure its convergence? To do so, I have plotted the inverse of the fitness function as I use keys that are more and more uh, different from the right key. And as you can see, this overall fitness function increases as I approach the solution. These are three different decoding attempts for the previous text. Okay, the complexities I have faced in my project are data management issues, finding suitable fitness functions, handling a lot of text files, the comprehension of code from another author, and that the computational time has compromised the working process. The results are that I have fulfilled the objective of developing a disencrypting program, but when I use the fitness function based on the word recognition, it is too slow. Is this genetic algorithm optimal for this kind of problem? I think not, and I have also found what we could name the Neanderthal problem, that is, for certain attempts, the population evolved in such a way that it ceases to evolve towards the solution, so there is no proper final key for solution. Okay, I'm aware this presentation does not cover all the details needed to fully understanding how my functions work and how I have tested them, so please address me if you have any doubt. Now let's check the results. Go to MATLAB, it has ended, so go to the folder. Here I have two text files, one is current solution and the other one is named processed final solution, which is the same text but with an implemented word recognition that sets spaces between words. That's all. Thank you very much.